Now we're going to look at graphing a one period of a shifted tangent function. So graphing a function of the form y equals a times tangent of bx minus c plus d. So again, the a, absolute value of a is our stretching factor. So you get our b as we did in the last part, and that's going to help us get our period. So it's going to be pi over b. Identify c as and determine the phase shift. So the phase shift is c over b. Draw the graph of y equals a tangent to bx, shifted to the right by c over b and up by d. So if d is negative, it goes down. If c is negative, it'll go to the left. So sketch the vertical asymptotes which occur at c over b plus pi over 2 absolute value b times k, where k is not an integer, and plot any 3 points and draw the graph. Okay, so we're looking at y equals negative 2 tangent of pi x plus pi minus 1. So right now it's going to be shifted down by 1. Our period is going to be pi over pi, which is 1. So as before, I will go ahead and get rid of all these. Okay. Get red back. And this here is plus pi, so my c is negative pi. So c over b is going to be negative pi over b, or negative 1. So it's going to go to the left one. So our period, we said, was 1. So I'm going to scale this as, let me think about this. I don't get enough detail into this. Decisions to make. I guess I could say 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. Negative 0.5, negative 1, negative 1.5, negative 2, negative 2.5, negative 3, negative 3.5, and negative 4. Okay, so we would have had the asymptotes at negative 0.5 and 0.5, but we're shifted by 1. So this would go 1 over, which lines up here. And this would go 1 over, so it lines up here. So every 1, we're going to have 1. And given that it's a periodic function, it's going to repeat on top of itself. You know, it just shifted over itself. And then this is going to go down 1, so our center line is going to be down here instead. So what would have crossed on the x-axis is going to cross on this, what we call the center line. And I know it looks like it's not centered, but you have to remember this graph goes up forever and down forever. Okay, and let's go ahead and plot some points. So we know in the middle of the asymptotes is where it would be crossing the center line. Oh, we have a leading coefficient negative 2. So it's going to stretch it by 2 and invert it. So between, for example, the center and the asymptote, you would have had a point that would have been at, would have produced a 1. So in this area would have produced a 1, which would move it up to there, because everything shifted down by 1, because of the negative 1 here. Okay, but we're multiplying by negative 2, so it's going to be at negative 2. So instead of going up 1, it's going to go down 2. And then this one, instead of being down 1, it's going to go up by 2. So we get this kind of a graph. I know they just want one period of it, but I'm gonna do more. Okay, so once again, it's going to be here, and it's going to be down here. My curve is not very good, I apologize. That was not, sorry, this was not a good one, I apologize. That's going to be there. Oh my gosh, I should just undo that one. That was a really bad one. Okay, I'm getting too sloppy. So once again, we were here, and we were down here. And something like that. Okay. Graphing tangents. So how to identify horizontal and vertical stretches of the graph of a tangent function. Find the period P from the spacing between successive vertical asymptotes. Write f of x equals a tangent of pi over p x. Determine a convenient point x f of x on the given graph and use it to determine a. So example 3 here, find our formula for the function of the graph. So it looks like it's not shifted horizontally because of it is going from through the center line. It's not shifted vertically either. Our center line is right here at the origin. But my period, and we have -4 to 4. So our period is going to be 8. So remember that period equals pi over b. So if I were to solve for b, p times b equals pi. And if we divide by p, b equals pi over p. So it's pi over 8. That's where they came up with that. And vertical stretching, let's think about that for a second. At this middle point between the crossing point and the asymptote, it should be at a 1. This is at a 2. So our a must be 2. So f of x should be 2 times tangent of pi over 8 times x. And there's plus c. There's no plus c. C is 0 and d is 0.